Question 7 is taken from paper 1 from 2020, and it was question 4 on that paper. It's a functions question. We have to find the value of 7 when it's inputted into the inverse function, first of all. Now then, we could, in theory, figure out what the inverse function is by rearranging the formula given here. But if we think about how inverse functions actually behave, if I take an input of 7, okay, I plug it into the inverse function. So I apply f to the -1 to it. I'm going to get some y value out of it, okay? That's the value that we want to find. Conversely, if I reverse the process, if I start with the y value and I apply f to the y value, then I'm going to get the 7 back. So how can I use the function without having to find the inverse function? Well, all I'd have to do is to set the function f of x equal to 7, because as you can see, 7 is the output in this flow chart here, okay? And y would be the input, but it doesn't really matter. As long as I set f of x equal to 7 and then figure out what my input would have been, then it will work. So to do that, we just have to write down our function. So we have 3x subtract 7 over x subtract 2. And we know that we'll get 7 at the end of it. If we rearrange, we're going to have 3x subtract 7 is equal to 7x subtract 14. Collecting x's together and constants, we're going to have 7 is equal to 4x. So in other words, x is going to be 7 over 4. Now, as I stated, you can do that by finding the inverse function first and then plugging in 7, if that makes more sense to you. So that's 2 marks for that. For part B, we have to find ff. Sometimes, just so you're aware, they could write this as f to the power 2 of x, where you're applying f twice. And we have to show that we get this reciprocal, not reciprocal, but this algebraic fraction here with a linear numerator and a linear denominator. So we've got to find a and b. Now, in order to do that, if I take the function f, my input has to be the function f as well. That's what happens when you apply f twice. So in other words, I'm plugging 3x subtract 7 over x subtract 2 into itself. Okay, so that's my input. So that means that wherever I see an x, I'm going to have to replace it with 3x subtract 7 over x subtract 2. Okay, so I subtract 7 and then I divide by, again, 3x subtract 7 over x subtract 2. And this time I have to subtract 2 from that. So the first step always looks really, really bad. It looks really, really complicated. We do have something in our favor, however. We have a denominator, which is the same top and bottom. I need to clear that fraction. Because I have the same denominator in the numerator and in the denominator, if that makes sense, it's a fraction within a fraction. If I times everything by x minus 2, that denominator will clear and I won't have a fraction inside a fraction anymore. So we do this. I'm going to just drag my working out down over here now. So we're going to have 3 lots of 3x subtract 7. Now that's what you'll be left with if you multiply by x subtract 2, because it will clear the denominator. In the same way as if you multiply 1/2 by 2, that clears the denominator. But to keep everything in the same proportion, I'm going to have to multiply the 7 by x subtract 2 as well. Okay, now the same rules apply in the denominator. I can times everything by x subtract 2. Nothing will change except that the fractions will be cleared. So I'm going to have 3x subtract 7 subtract 2 lots of x subtract 2. I think this is the easiest way to do it. There are other ways. You could expand and simplify, collect like terms top and bottom, and then clear the fraction. But I find that takes longer and it's liable to cause mistakes in the algebra. Okay, this has fewer steps. So let's just collect like terms, expand and simplify. So we're going to have 9x subtract 21, subtract 7x plus 14 over 3x subtract 7, and then subtract 2x, watch out for your negatives, plus 4. Okay, nearly there. Let's just collect like terms now. So for the x terms, we're going to have 2x on top, and we've got negative 21 plus 14, so that's going to be negative 7. And on the bottom, we're going to have x, so 3x subtract 2x is x, and then negative 7 plus 4, which is negative 3. So I can see that my denominator checks out. Hopefully the numerator checks out as well.